Hi, fifth graders. I hope you're doing well. This is your lesson 2 for math for this week, and it is dividing whole numbers by decimals. And I know we've already done that, or 2 lessons of that already. However, we're going to change it up a bit because this one actually kind of talks a little bit more about remainders and what you do when a number doesn't go in perfectly. As a reminder, if you are watching lesson 2, you've already watched lesson 1, and so you know that using Castify or Screencastify, I'm going to be going in and out of present mode and not in regular so that I can actually write on the screen for you. All right, so here is our goal by the end of this lesson. Today, we will look at word problems that involve solving dividing whole numbers by decimals with remainders, and that is so that we can understand expectations and how to solve and write remainders. We know when you divide whole numbers that y'all know perfectly well how to write remainders or how to deal with them and how to write them as fractions. However, now that we're dividing them or dividing decimals, we want to make sure that we know the proper instructions on how to write them as decimals. And down here, I have just put for you the standard that we've been focusing on since we've begun virtual learning in the Gator Gallery page, and it's at MVT 7. And this part is just the dividing whole numbers. Technically, that base 10 number base 10 systems standard actually involves all operations within decimals, but right now we're focusing on dividing. Okay, so here's our first problem. Actually, I'm gonna put myself right down there. All right, so we have 93 hundredths divided by 8 tenths, and so we are splitting up 93 hundredths into 8 tenths, and so I have written it in standard algorithm form here because you are splitting up the 93 hundredths and you're splitting it up into 8 tenths, okay? And so what you're splitting up goes in your house, it's your dividend. What you're dividing by goes outside as your divisor. Remember, your dividend, when you write it like this, is always your first number, your divisor is your second number. All right, I don't know my facts of 8 tenths. We talked about that before. So for this one, I actually do need to shift the decimal over. And so you're going to see me do that. I've shifted my decimal over. What I'm really doing there is multiplying 8 by 10. I cannot multiply, or I'm sorry, 8 tenths by 10. I cannot multiply 8 tenths by 10 and do absolutely nothing with the 93 hundredths. Whatever I do to the outside, I have to do to the inside. So my trick is to shift my decimal place over. What I'm actually doing is multiplying 93 hundredths times 10. Well, when I multiplied 8 hundredths times 10, I got the whole number 8. And when I multiplied 93 hundredths times 10, I got 9 and 3 hundredths. Remember, it's okay to leave a decimal in your dividend or the number inside your house. It's not okay to leave a decimal in your divisor because you have to know your facts of that number, and we don't know our facts of decimals. All right, then you notice that now that my decimal is still in my dividend, I had to carry it straight up. So I carried it straight up. And so now I can begin to solve as if I'm just thinking about how many times can 8 go into 93. Well, I know that 8 can go into 9 one time. So 1 times 8 is 8. And so then when I subtract, I end up getting 1 left over. Okay, I need to continue to solve though because I still haven't used this 3 here. So what I'm going to do is I'm going to carry my 3 down. Okay, now I'm thinking about how many times can 8 go into 13. All right, 8 can go into 13 once. All right, I'm going to finish my problem over here in step number 3. So I just have it rewritten here for you just so that you can see it. Again, 8 went into 13 once, and then 1 times that 8 is 8 again, and I end up being left over with a 5, okay? However, I'm still left over with 5. It would not make any sense if I chose to write my number as, and let me show you this, I'll pop out of, I'll pop out of present mode just for a second. If I were to write, this would not make any sense. Okay, because I have a decimal in this number and I have a fraction in this number. So that would not make any sense for me to do that, okay? So what I actually need to do is, sorry, I have to click through these steps real quick. what I actually need to do is keep going, okay? But I don't have anything left to carry down. So all I'm going to do is add a 0, okay? And I'm going to carry that 0 down. All right, so now I'm thinking about how many times can 8 go into 50? All right, 8 can go into 50. Well, I know 8 times 6 is 48, which is very close to 60. So 8 can go into 50 6 times. And there's just like my kind of pop up of like my brain thinking, okay, how many times can it go into 50? 6 times 8 is 48. And then you're just going to see me rewrite the problem like smaller here just so we can kind of see it better. Okay, so 8 went into 8 went into 56 times to give me 48. And now I'm going to subtract again. All right, I'm left with 2, okay? Again, it wouldn't make any sense for me to write something as 1.16 and 2 eighths. Okay, that doesn't make any sense. So I have to keep solving. In 5th grade, we only ask you to keep solving to the thousandths place. You are welcome to stop at the thousandths place. So again, I add another 0. I carry it down. And now I'm thinking about how many times can 8 go into 20? 8 can go into 20. Well, I know 8 times 2 is 16. That's pretty close. Let's say 8 times 3 is what, 24? Nope, that goes over, so it can only go in those 2 times. And again, how many times can 8 go into 20? 2 times 8 is 16. All right. However, you notice I've reached my thousandths place, so I can actually stop there. Some of you might want to keep going just to see, hey, am I going to need to round this thousandths place up or not? If you kept going for this one, it's actually pretty interesting because it would end very, very soon. And I'm going to pop out of present mode and just show you that. Oh, sorry. Okay. So let's see if I can show you that real quick. I need my eraser. Okay. All right, so if I kept going, how many times can 8 go into 20? 8 can go into 20. You remember? 2 times. 2 times 8 is 16. I subtract. Oh, I'm sorry. I already did I apologize. I already did that part. Up there, I showed you that part. So now I'm just saying how many times can 2 times 8 is 16. There it is. And I subtract and I get 4. All right, I'm going to add one more 0 and you'll see how this actually ends. How many times can 8 go into 40? 5 times. 5 times 8 is actually 40. And so you end up being left with 0. Again, you only have to go to your thousandths place, so you don't have to go here. You don't have to do this part. You can actually just stop at your thousandths place. So a perfectly suitable answer for this one is this 1 and 162 thousandths. Some of you might wanted to go to that next place value just to see if you needed to round this up. So another acceptable answer for this one would have been 1 and 163 thousandths because you would have rounded that 5 up. And remember, you only have to go to your thousandths place. All right, we're going to show, I'm going to show you a few more. I'm going to stay out of present mode just so you can kind of see how these work. All right, as I solve. So I have Nathan takes 42 minutes to run a distance of 4.5 miles or 4 5/10 miles on a treadmill. How long does it take for Nathan to run 1 mile? Excuse me. Sorry. Okay, so I first want to write my equation, and I'm actually going to see if I can do this like off to the side in a color that you can see. And so I have 42 minutes being split across 4.5 miles. So I'm dividing 42 divided by 4.5 or 4.5, okay? So that's my equation. All right, I'm going to set that up in standard algorithm. So I have 42 being split across, I have 42 minutes being split across 4.5 miles, okay? Remember, dividend goes in the house, divisor goes outside. All right, I have to do something about this though. I have to shift this number over, okay? I have to shift this over to make this usable, all right? So what I'm really doing is multiplying 4.5 times 10. Well, 4.5 times 10 would actually end up giving me the whole number 45, okay? But because I multiplied that by 10, I have to multiply this by 10. Okay, or shift my decimal over. So what my new equation is actually going to be is 420 divided by 45. All right, I'm going to go ahead and rewrite this here for you just so we can see it a little bit better in standard algorithm, and because like my space is kind of limited. So my new equation was, how many times can 45 go into 420? Okay. All right, now I'm going to do something that you might be like, I wonder why she did that, but I just don't want us to get confused later on down the road. So I'm actually going to carry out my division line just in case I need to go over, because I know I'm going to probably have remainders here. All right, and I'm actually going to put a decimal right here, and I'm going to carry a decimal up. I know that 0 is my ones place. There's 0 value in my ones place. And so I know that my decimal comes next, okay? And I know since I'm doing remainders here, I might want that decimal place at some point in the future. So now I'm going to think, how many times can 45 go into 420? Well, 45 can't go into 4, so I know it goes in 0 times here. It can't go into 42, so it goes in 0 times there, but it can go into 420. All right, I don't know my facts of 420, and that's totally fine. But I am going to go off to the side and say, what can I multiply my facts of 45. What can I multiply 45 by to get me close to 420? Well, if I think about it, 45 times 10 would just be me adding a 0, right? So that would be 450, which I know is more than 420. So maybe if I just do it by 9, okay, because that's 1 less than 10. Let's see if that works. 9 times 5 is 45. 9 times 4, I know my class loves their facts of 9s. So 9 times 4 is 36, correct? Yep, 36 plus 4 more is 40, okay? All right, so I know that 45 can go into 420, can go into 420 9 times. I'll put my 9 here. 9 times 45, I just figured out, is 405. And then I'm going to subtract like normal. I know that I went in the correct number of times because I only have 15 left, and 15 is much less than 45. All right, but I need to keep going. So I'm going to add my 0 like I did before. And now I'm thinking about how many times can 45 go into 150? 45 times, I don't know, 45, I'm going to think about that. 45 is pretty close to 50. If you're thinking about 50 times 3 would be 150. So maybe 45 times 3 would work. Let's see. 5 times 3 is 15. Carry my 1. 3 times 4 is 12, plus 1 more is 13. So I know that it can go in 3 times. If I went any more, I would go over that 150 mark. So 3 times 45 is 135, and I'm going to subtract. Okay, and then I'm end up left with 15 again. I'm going to add another 0 and carry it down. All right, now how many times can 45 go into 150? I already figured out it can go in 3 times. Going to give me 135, and it'll actually keep going. You'll notice when ones like this are going to repeat, and you can actually just stop right there at that hundredths place, okay? Or I guess I should keep going since I told y'all to go to the thousandths place. How many times can it go in 153? 3 times 45, 135. And it'll just keep repeating. You've ever solved ones like this or seen your parents solve ones like this on their calculator? It's one of those ones that just keeps repeating and repeating. I can actually show y'all on my phone here. 42 divided by 4.5, and see how it's one of those ones that just has the numbers just repeating and repeating. It's like infinite. It goes on forever. All right, so I'm going to do the next few in a separate video just so that you can actually, you might, like this one's kind of getting long, so that you can see it a second time in a separate video in case you need more review, or you can stop here. So like Miss S likes to do, the last thing I'm going to show you is we put it in a sentence about how long does it take for Nathan to run 1 mile. And it takes Nathan about 9 and 33/100 minutes to run 1 mile. You kind of don't know like where to round to. You could also say it takes him about 9 minutes, or it takes him about 9 1/4 minutes to run 1 mile. Kind of depends on where you choose to round to, or if the problem specifies. So the next two I'm going to do in another video in case you need more review on this.